If you remember back when we talked about speed, you might remember the fact that I talked about how speed is really just a conversion factor between distance and time, right? So you have a distance and you want to figure out how much time it's going to take, use speed. You have a time and you want to figure out how much distance you can travel, use speed. So it's a conversion factor, right? Well, it turns out that velocity can be the same kind of thing. Only instead of having distance, it's got displacement. But that's still okay, right? So the displacement is this delta x thing, right? Which is, if you want to figure out the velocity, you take the delta x, the displacement, and you divide it by the time, right? Sort of similar to your distance divided by time, only it includes the direction, okay? So that's okay for figuring out velocity, but oftentimes we don't want to figure out velocity. We want to use the velocity to be able to do something. Like if I had an insect, for example, in my last video. I had an insect, I know what its typical velocity is. I could go ahead and try to calculate out in how many seconds would it take to go a certain distance. So it would be a conversion factor between the two. But to make it a conversion factor, I really need to rearrange it again. So I'm going to multiply both sides by t, and I end up with this, right? So delta x equals v times t. Now I added in plus 0 just for the same trick as I did when we were talking about speed, so don't freak out about that. Delta x is the displacement, v is the velocity, t is the time. Now, you may notice, just like we talked about with speed, that the format for that formula right there is exactly the same format as it is for the slope-intercept form for a line, right? Y equals mx plus b. And so in place of the y variable, we can go ahead and put in a displacement. But if we do that, we have to make sure that anytime we graph it out, the y-axis must have displacement on it, because these two go together, okay? So this is the y-axis, it's the vertical axis, and we're going to put displacement on it right there. Notice here, we've got the x and the t go together, and so anytime there's an x-axis, we're talking about motion here, we're going to put time right there. And now typically, I'm going to be honest with you, typically time goes on the x-axis, so that's kind of a way to cheat a little bit. If you're confused, if you can't remember for sure, and you got time, put it on the x-axis. And the reason for that is because the x tends to be the independent variable, and time is the independent variable oftentimes. So oftentimes you could say, how far will that bug get in 5 seconds? How far will that bug get in 10 seconds? How far will it get in 15? I'm choosing those times. That's the independent variable. The dependent variable is what we measure as a result of that, which is on the y-axis. So typically time is on the x. That plus b right there is the intercept, and there's typically no intercept, so we're not worried about it there. So what the heck is this thing in between here, the conversion factor? Well, for a graph, for a line, it's a slope. For the displacement in time, it's the velocity. And so let's take a look at what that would be here. Let's say we've got the object starts at the starting line at a time is equal to 0. So right here, we've got t equals 0 right there. And the displacement is 0 because that's where it starts, right? And so it wanders around like so, and then it ends up right there at, let's say, 10 seconds. Okay, so at t equals 10 seconds, it ends up right there. Okay, now the displacement is the difference between where it starts and where it ends. So I'm going to go ahead and trace this across and say, let's say right there it traveled 5 meters. Okay, now just keep this in mind. It actually traveled quite a bit farther than that, right? Because it went too far and then came back, and then went too far again, and then came back, and then went too far again, and stopped at 10 seconds. But the distance that it ended up away from the starting position is 5 meters, right? And so if you compare those two, that's what you get, 5 meters. So what's the speed, right? Well, the speed is, we don't know because we don't know what the total distance is traveled. But we do know the velocity, right? So velocity is equal to the displacement divided by the time. And so that is 5 meters divided by 10 seconds, or 0.5 meters per second. Now, this, I think you'd agree, this is usually in the positive direction up here. So that's actually a positive 5 meters. This would be down here in the negative direction for displacement. So should be a positive, and therefore that should be a positive. Whenever you have a velocity, don't forget to put the direction unless it's totally obvious, like something falling down. The velocity for the object falling down is going to be downward. So it's totally obvious. If you say the velocity is 5 meters per second, I'm going to assume that it's falling downward, right? In this case, we don't know. And so in this case, we'd have to say it went from here to there, and so it went in the positive direction. So that's the velocity. Now, check this out here. If I wanted to, I could go ahead and draw a line between those two, like so. And I could ask you for that line right there, what would be the slope? Well, notice that slope, remember, is rise over run. And so what's the slope? How much did it rise? Well, I only know those 2 points for sure. So it rose positive 5 meters, and it ran 10 seconds. And so as a result, I end up with exactly the same thing. So you can see that the slope and the velocity are going to be the same over that time, which is pretty cool, right? So you could use the slope to be able to figure out the velocity if you can't figure out anything else. So hopefully that helps. Now you may have noticed something a little weird in that last graph, and that is that the object went all up and down, meaning it went away from the start and then back towards the start and then away from the start again over that period of time, but I didn't care about any of that stuff. I just picked the point at the beginning and the point at the end and then tried to use that. So it seems kind of weird that you would do that, but in reality we do that quite a bit. For example, oftentimes people ask, how was the drive to Chicago? I got there pretty fast. We made pretty good time. So what does that mean? So let's say it's 80 miles to Chicago. I know I said wouldn't use miles again, but let's use 100. So it's 100 kilometers to Chicago. And I was able to do it in 2 hours. So that's pretty good, right? So for Chicago with a lot of traffic, that's not bad. So 100 kilometers in 2 hours. So what's my velocity? Well, my velocity is towards Chicago is 50 kilometers per hour. So does that tell me anything about it? Is it possible that there were times when I was stopped in traffic or went a lot faster? Sure, yeah, but I don't think people are really all that excited about or interested in learning how fast you're going at every particular moment. You know who is though? Police officers. So it is very important that you know how fast you're going in your car at any one particular time, but nobody other than you and a police officer really cares about that. So we do have 2 different types of velocity, and so we want to talk about that here real quick. So we have average velocities. So if I ask you in general how fast are you going, so over the whole time period or the whole trip or whatever, how fast are you going? I don't care about the details. I don't care about what happened at every particular moment. I just want to know roughly how fast, or in general terms, how fast you're going. On the other hand, if you're a police officer, you definitely want to know how fast you're going at that one moment. So the police officers maybe are gunning, they're using their radar. They want to know how fast you're going right then when the radar hits you. So right now, how fast are you going? And we call that instantaneous velocity. Instantaneous. It's a big word, I know. But it has a little word in it, and that should make it a lot easier, and that's instant. Right this instant. Right now, how fast are you going? That's what I want to know. How fast are you going this instant? And so you can see the difference right there, right? This one is in general terms, what are you doing? This one is right now, how fast are you going? This is what you find on your speedometer, if you're talking about speeds, right? So you find that, how fast you're going. How fast am I going right now? If you used your speedometer and only gave you an average speed, you'd be in trouble because it wouldn't tell you at all about what you were doing at any one particular time. It would say over the course of your trip, this is what you basically have done. So you may be going 80 miles an hour on a freeway, which I don't recommend, and then stopped at the rest stop, and the speedometer would still have a value of probably a little bit less than 80 miles per hour. Because you, on average, were going 80 miles per hour, even though you're stopped right now. So would that be very helpful? No, it wouldn't. On graphs, it looks kind of like this. So let's say I have this particular point right there, okay? So if I wanted to know how fast you were going right at that particular point, I could use the trick that I talked about just a few minutes ago of figuring out what the slope of the line is right there. So I could make a line like this, and then use that line figuring out the slope. The rise, which is this, it's actually downward, right? So it's not really a rise. And the run, which is that, will tell me what the slope is. So I could figure out exactly what the slope is right at that particular time. That would tell me the instantaneous velocity. That's what calculus is. The first semester when they do derivatives, they teach you easy ways to do it. Calculus is not that bad, so don't freak out. Hopefully you're in Calc or thinking about taking it. It's pretty useful sometimes. On average, though, instead of saying at that one particular point and figuring out what the slope of the line would be at that one particular point, let's say instead I wanted to figure out what the slope was between two separated points. So like that. So between two separated points, like the start and the end. Check this out. I was going away from the start, and then I turned around and went back towards the start, and then I went away from the start again. What the heck? But I don't really care about any of that stuff. I just want to know on average how fast was I going. So if I figure out what that line is between those 2 points, I can figure out the average speed, average velocity in this case, because I'm going to include a direction as well. So that's pretty cool. So you can see that they're found in different ways, and we're going to practice that a little bit in class, so hopefully that makes sense. All right, so we talked about a little bit about motion graphs to kind of give you a foundation that you can build on in class. We're going to do a lot of motion graphs, a lot, over the course of the first semester. So just keep that in mind. It's going to come up again and again and again, and we're going to use spreadsheets, and we're going to use video tracking systems, and we're going to use all sorts of different mechanisms for tracking the graphs. Either you make them or you'll have to read them. So they are important, and hopefully we're going to practice that quite a bit. If you have questions, awesome. That's great. I hope you do. You can go ahead and watch this again. You can go ahead and check out the resources on the website. You can text me or email me or use remind.com to get in touch with me, or you can come in the morning, or you can bring those, and this is the best one, bring those questions to class, because there's probably a bunch of people who have the same questions. So let's talk about it. This is why we do this, right? So you watch this at home, get the boring stuff out of the way, and then we come in and talk about it and have a good time. So hopefully that makes sense. If you have questions, again, let me know. Thanks for watching.